Hi everyone, today's lesson is on areas of trapezoids and regular polygons. So let's get started. Warm up, find the area of each figure. So in order to find the area of this shape right here, we need to remember a few things. We have two triangles and these look like they're the same. We have a shape right here. Now if these are both the same, okay, length, and it's a right triangle, this height is going to be 8 root 2. X root 2, okay? So the area of a triangle isn't going to use the 8 root 2, but we're going to use that for the area of this shape in the middle. It looks like a rectangle. So our job is to find the area of two triangles plus the area of your rectangle. So we've got the area of the triangle, which is going to be 1/2 base times height. So this is my base and my height, because remember, for the area of a triangle, the base and the height have to be perpendicular. So we've got 8 times 8 and plus the area of the rectangle here, which is 10 times 8 root 2. Now, this value here, remember, we need to multiply this by 2 because we have two triangles. So it's 2 times this whole thing. So this 2 is going to cancel with this 2. And so what I have is 64 plus 80 root 2. And because this is area, you would put the whole thing in parentheses and you would put unit squared like that. This area of this triangle, now this looks like an equilateral triangle. So 10, 10, and 10. We also know that this height comes down, breaks this into half. And we also know that this is a 60 degree, 60 degree, 60, which means this little part here is 30. So across from the 30 is A. Across from the 90 is 2A, which makes sense. Across from the 60 is A root 3, so 5 root 3. So to find the area of this triangle, you're going to say the area of the triangle is 1/2 the base times the height. Please remember that when you're finding the base, it's the entire base of the triangle. So it's 1/2 10 times the height, which is 5 root 3. So half of 10 is 5. 5 times 5, that's a 1 here. So the area of my triangle is going to be 5 times 5, which is 25 root 3 units squared. Continuing with our warm-up with what we learned on day 1, find the area of each figure. A rhombus has a perimeter of 20 and one diagonal of length 6. Well, if the perimeter is 20, remember about a rhombus, rhombuses have all sides are congruent. So we're going to take 20 and divide by 4. So each of these sides are 5, okay? Now, one diagonal has a length of 6. Okay, so the other diagonal, remember, is perpendicular. So I'm going to say we have a 3 and a 3. This becomes a 3, 4, 5 triangle. So you see that? 3, 4, 5, because it's a right triangle. So in order to find the area of our rhombus, okay, which is those diagonals are perpendicular, it's going to be 1/2 diagonal 1 times diagonal 2. So that's going to be 1/2 diagonal 1, which is 6, we were given that, times diagonal 2, which is 4 plus 4, which is 8. So half of 6 is 3. 3 times 8 is 24, and this is units times units, so units squared. So that's my area. The diagonals of a rectangle are 8 centimeters long. Now, something to remember about a rectangle is we know that the diagonals are congruent. The diagonals of a rectangle are 8 centimeters long, and they intersect at a 120-degree angle. So if I drew another diagonal in here, okay, and we made this 120 degrees here, find the area of the rectangle. So the area of a rectangle is equal to base times height. We don't have the base, nor do we have the height, but we do know that the length of the diagonals are 8, which means this is 4, this is 4, that's 4, and that's 4. What else we know is that if we were to split this up and we were to draw a line like this, okay, like that, I need to find this height, okay, first, and I need also to find the length. But if I broke this up here, that's going to make this a 60-degree angle, and this is a 30, and this is right. Across from the right angle, so what you have is, and let me see if I could redraw this one part right here, where that's a 30 and that's a right angle. Across from the 90 is equal to 2a, which is 4. So if I set 4 equal to 2a, I know that a is equal to 2. So across from the 30 is 2, which means this height here is 2. So if from here to here is 2, that means the whole length here is 4. In addition, we know that across from the 60 would be a root 3. So if a is 2, this is going to be 2 root 3. But the whole length here is going to be 2 root 3 plus 2 root 3, which makes 4 root 3. So to find the area, it's going to be the base times the height. So it's going to be 4 root 3 times the height, which is 4. And so that's going to be 16 root 3, and that's units squared. And that's the area of our rectangle. Okay, so new stuff. We know the area of a parallelogram is base times height, but making sure that we say that the base is always got to be perpendicular to the height. Very important. This is so important. Now, to find the area of a trapezoid, I know I did cover this in day 1. However, a lot of people will split this up into parts. And so you really have this large triangle plus this triangle here, plus this shape in the middle here, which could be a square or could be a rectangle. So when you add all these parts up, you end up getting the area of a trapezoid, okay? And the area of this trapezoid is going to be height divided by 2 times the sum of the bases. So base 1 plus base 2. So that's the formula for the area of a trapezoid. So we're going to be using that to find the next problem. So we know that the area of a trapezoid is equal to the height divided by 2 times the sum of the bases. Okay? And so keep in mind that the heights have to be perpendicular to the base. So that means that this is my height here. So that's going to equal 3 divided by 2 times the sum of the bases, which is 5 plus 8. So for this problem right here, we have 5 plus 8, which is 13. 13 times 3 divided by 2. So we're going to get a fraction. So the area of my trapezoid is going to be 13 times 3, or divided by 2. So 13 times 3, 9, 39, and 39 divided by 2. Now I could say 39 halves is equal to the area of my trapezoid, units squared. I could also divide that out, and you could do either one, but either one is fine. Let's see. I think 39 halves is fine. Just keep that as units squared. Let's talk about the median of a trapezoid. Now, the median connects the two midpoints, where that's congruent to that, and this side here is congruent to this side here. Not necessarily the same, only the same if it's an isosceles trapezoid. So the median of a trapezoid is the line segment that connects the midpoints of the two legs of the trapezoid. So what we remember about a median is that the median is equal to the sum of the bases. So I would say divided by 2. So I would go base 1 plus base 2 divided by 2, and that's my median. Well, that's actually almost my formula for my area, because the formula for the area of a trapezoid is equal to 1/2 the sum of my bases times the height. Now, I usually say height divided by 2 times the sum of the bases, okay? But you could also write it as 1/2 of this. So really, what you're seeing is this length here. You're seeing this part, this 1/2, base 1 plus base 2 times the height. What you're seeing is that this part right here is your median times your height. So another formula for area of a trapezoid is the median times the height. So you have two formulas for area of a trapezoid. Median times the height, 1/2 base times height. And again, the way I write the area of a trapezoid is height divided by 2 times the sum of the bases. So because multiplication is commutative, I can multiply this height times 1, and you just have height divided by 2. So to find the area of these two trapezoids, we're still going to use the formula. So we're going to say height divided by 2 times the sum of the bases. So for this first one, my height is this length right here. okay? And I see that this is 60, and this is 90, which means this length here is 30. This angle is 30. Across from the 90 is 2a, so I know that 2a equals 12, so a is equal to 6, okay? Then across from the 60 is a root 3, so that makes this 6 root 3, okay? So my area of my trapezoid is equal to my height, which is 6 root 3, divided by 2, times the sum of the bases. Now remember, the base, it's the whole base plus the whole base. So it's going to be 15 plus 30. And so simplifying, I'm going to divide this 2 into this 6 3 times. 30 plus 15 is 45. So what I have is 45 here times 3. 45 times 3 is 135 root 3, and that's units squared. And so that's the area of my trapezoid. For this one, my area of my trapezoid is going to be height divided by 2 times the sum of the bases. Now remember, this is my height right here. I see that this is an isosceles trapezoid. So this being an isosceles trapezoid means that this height, is going to come down here, whereas this little length is equal to this length right here. So if I take 23 minus 7, so 23 and take away 7, I'm going to get 16 left. And so what that means is that this length here is 8. And I see that if my hypotenuse is 17, that makes this an 8, 15, 17 special right triangle. So the area of my trapezoid is going to be the height divided by 2. So 15 divided by 2 times the sum of my bases. And the sum of my bases is 23 plus 7. 23 plus 7 is equal to 30. And I'm going to take half of 30, which is 15, and 15 times 15 is 225 units squared. Find the area of this trapezoid right here. And so the area of this trapezoid, again, is height divided by 2. So the area of the trapezoid is equal to my height divided by 2 times the sum of my bases, which I only have a little bit of this information. So what I need to do is, it looks like I'm going to need to draw a perpendicular line here with my base to make my height. And in doing that, because this is now perpendicular, this does cut this into, let's see, that's 10. That's 8 root 2. That would have to be 8 root 2. This being a 45, because that's going to be a 90 here. And 90 from 135 is 45. So we have 8 root 2. So my height is 8. And let's see here. This part right here is, if this is 8, and this whole length here is 10, that would make this little part 2. So 10 plus 2 times 8 divided by 2. So again, that's going to be 8 divided by 2, which is 4, times 12. And 4 times 12, units times units, is units squared. So that's 48 units squared. So just to reiterate, I want to draw that one more time. What I did was I drew in a right triangle like here. I drew a perpendicular line here. In doing that, that made that right. And so 135 minus 90 degrees does make 45 degrees right here, meaning x root 2. So that's 8 root 2. And if you don't remember the special right triangle formulas, you can just say this is x and this is x, and then you would use the Pythagorean theorem to do this, right? Equals 8 root 2 quantity squared to find the height, which is just 8. Okay, cool. The median is 6. So this is a trapezoid, and the height is 3. So remember, the median is this line segment that connects the two midpoints, where that equals that and that equals that. The median is 6, and my height is perpendicular, and that whole length is 3. So two formulas that I have are the area of a trapezoid is equal to the height divided by 2 times the sum of the bases, which I actually don't have the sum of the bases. So I'm going to use this formula, which says the median times the height. So the area of my trapezoid is going to equal my median, which is 6, times my height, which is 3, which is units times units, which is going to equal 18 units squared. Okay. Now these two problems, well, this one in particular, find the area of a trapezoid, and I don't know that this is an isosceles trapezoid. So the area of my trapezoid is going to equal my height, which I don't have, divided by 2, times the sum of the bases, which is 7 plus 15. So I'm thinking that because that is a 53-degree angle, I'm going to have to do some right triangle trigonometry here. So I'm going to come down here at a 90-degree angle, and I need to find my height, okay? So if I'm standing here at this angle, I see that that's opposite, and I've got the hypotenuse. So I would say opposite and a hypotenuse, using my SOHCAHTOA, sine, cosine, tangent, is going to be sine. So on the side, I'm going to go sine of 53 degrees is equal to height divided by the hypotenuse, which is 10, opposite over hypotenuse. And I need to find out what sine of 53 is. So I'm going to do that. I'm going to use my cell phone calculator. So I'm going to go 53. Make sure your calculator is in degrees. That's important. 53 sine is this value right here is about 0.7986 is equal to my height divided by 10. I'm going to cross multiply, and so my height is going to equal 10 times 0.7986, and so that's just moving my decimal over one place to the right. So 7.9. We're going to say 7.9. Should we round off to 8? We'll say about 8, approximately 8. So that means these values here now are approximately. So the area of my trapezoid, okay, is equal to 4 times 7 plus 15. So 15 plus 7 is going to be what? 23. So 4 times 23. And times that by 4, so that's 12, 8, 92. So this is about 92 units squared. Okay, the area of an isosceles trapezoid, now those are kind of nicer because that means that when I cut these two sides are congruent. The base lengths are 12 and 6, the legs are 5. And the reason why I like isosceles trapezoids is because when I drop this down here, perpendicular to find my height, this length also is the same, meaning this is 6, that makes this 3. Oh boy, I think I did this one already. And that's a 4 because that's a 3, 4, 5. So we're going to go height divided by 2, so 4 divided by 2 times the sum of the bases, so 6 plus 12. So we have 2 times 18, and that's 36 units squared. Yep, I believe I did do this one. Maybe not today, but we did do this. So just the next thing that we're going to talk about is area of a regular polygon. Now, a regular polygon is any shape that has all 3 sides congruent, or all sides congruent. Regular meaning all sides are congruent, which means all angles are congruent. So any shape that has all sides and all angles congruent is regular, okay? So we're going to be finding the area of regular polygons. There's a couple of words that you're going to need to know. We know that the center of any regular polygon, this would be the center right here, okay? The radius is a length that goes from the center to a part of the point on the circle. It's always a good idea to try to make the radius attached to a vertice. We have a central angle, and a central angle is this angle in here, where if this was, let's say, 50 degrees, this arc that it encompasses is also 50 degrees, okay? My apothem, now some people call this an apothem, and some people call it an apothegm. I usually use the word apothem, but that's up to you and what you want to call it. Apothem or apothegm, either one is fine. So the perimeter of a regular hexagon is 12, find the radius, the apothem, and the area of the hexagon. Now, we haven't talked about the actual formula because in the past, what we've done is to find the area of this hexagon. What we've done is we've divided this up into triangles, found the area of a triangle, because these are equilateral, found the area of a triangle, and then what we ended up doing is multiplying that by 6. Keep in mind, this being a hexagon, each angle is 120 degrees because this sum of all the angles is 720 degrees. Divide that by 6, you get 120. So if each of these is 120 and I cut this in half, that makes these all 60. So of course that's 60, 60, 60, which makes it equilateral. Okay, that's why I said that they were equilateral. But the formula for the area of any polygon, okay, the formula of any polygon, all right, is going to be, I'm going to call that a polygon, is equal to 1/2 the apothem times the number of sides times the length of one side. And most people don't use the word L, the letter L, because a lot of times people think that that's like the length. It is the length, but they use the letter S. So they say 1/2 ANS. So apothem times the number of sides times the length of one side. So the length of one side times, that's the number of sides, and this is the apothem or apothem, okay? So the perimeter is 12. If the perimeter of this hexagon is 12, that means 12 divided by 6 is 2. So each of my lengths is 2. We know that the sum of the angles of any polygon is, if you remember the formula, it's 180 times n minus 2, okay? It's 180 times n minus 2. This being 6-sided, you'd go 6 minus 2, which is 4. 4 times 180 is 720. If I cut 720 into 6 parts, each of these angles is 120 degrees, okay? And if I divide this out and I say, okay, here's my center of my polygon, and I drop this down, that's my apothem, okay? And I say, well, cut that in half. Now that's a 60, 30, 90, right triangle. If this length, whole length from here to here is 2, this is 1, okay? So across from the 30 is A, across from the 60 is A, root 3. Okay, this is, we don't need to know this, but it is 2. So the formula for the area of the polygon is equal to 1/2 my apothem, which is root 3, times the number of sides. The number of sides is 6, times the length of one side. Now, don't get confused with this being a length of one side. That is not the length of one side. The length of one side is this whole length, which is 2. Okay, so you can at this point divide this 2, but be careful. It's not 2 divided into each shape, each number. It's 2 divided into one value. And so what we have is 6 times root 3. So the area is equal to 6 root 3 unit squared, because we have unit times unit, and that gives us our unit squared. Find the perimeter of an area of a regular hexagon that has an apothem or apothem of 6. So this is telling me that length is 6. Now, again, we know that this comes down here into 60 degrees. These are 120, but when I cut this in half, this now becomes 60. This is 30. Now remember, across from the 60 is equal to a root 3, which means I'm going to take my value, I'm going to divide by root 3, okay? And also, I'm going to divide by 3. Oops, let me fix that. Let me just work it out for you. 6 is equal to a root 3. We're going to divide by root 3 on both sides, okay? These are going to cancel, and I'm going to get a is equal to 6 divided by root 3. But we're not going to leave a root on the denominator. So what we're going to do is we're going to multiply this by root 3 over root 3. And so I get 6 root 3 over 3. And that 3 will divide into that 6 twice. So my A value is going to be A being A, not to be confused with my apothem. That could be confusing. My A value, which is across from my 30-degree angle, is 2 root 3. So across from the 30, because we know the apothem is 6, across from the 30 is 2 root 3. Okay, we don't need to know what's across from the 90, although if somebody were to ask you what's the value of the radius, you would say that times 2, which is 4 root 3. Okay, so the area of my polygon is going to equal 1/2 ANS, so apothem, number of sides, length of one side. So that's going to be area equals 1/2 my apothem, which is 6, times the number of sides, which is 6, times the length of one side, which is 4 root 3. So this 2 will divide into one of my terms. So 2 divides into 2 once, and a 6 3 times. And so what we have now is my area is equal to 3 times 6, which is 18, and 18 times 4 is going to be 72. So 2, 3, 4, 72. So that's going to be 72 root 3. Remember, numbers get multiplied with numbers. So 3 times 6 times 4, 72 times root 3 is 72 root 3 units squared. Okay, cool. Find the area. Oh, actually, I think I forgot. I found the area, but I didn't find the perimeter, and it asked for the perimeter and area. So the perimeter, let me just finish this. If this length is 2 root 3, the whole length together is going to be 4 root 3. So we have 4 root 3 times 6, because there's 6 sides. So that's, the perimeter is 24 root 3, and this is units, because it's units plus units plus units. So that's units. It's only when you multiply units. So units plus units is still units, but units times units is units squared. So keep that in mind. Okay, this one says find the area in the perimeter of a square that has a diagonal of 10. So if this is my diagonal and that's 10, okay, I know that these are congruent. I know that this is a 45, 45, 90, x root 2, meaning that's set equal to x root 2. And if you were to divide out the root 2, it's the same as saying divide 10 by 2 and multiply by root 2. So these are 5 root 2. Now, keep in mind, if you forget that, it is completely fine to say x, because I don't know the lengths of those sides, and go x squared plus x squared is equal to 10 squared. Let me just finish this. 2x squared is equal to 100. Divide by 2, x squared equals 50. When I square root both sides, I'm going to get 25 times 2, so that's 5 root 2 is one side. So you still have the option of doing that. It's just keep that in mind. You have, you know, there is a shortcut. So the perimeter is equal to 5 root 2 plus 5 root 2 plus 5 root 2 plus 5 root 2, or 4 times 5 root 2. And keep in mind, numbers get multiplied with numbers and roots get multiplied with roots, okay? So that 4 times 5 is just 20 root 2 units, and that's my perimeter. To find my area, I have to go side times side. So my area of my square is going to be 5 root 2 quantity squared. Keep in mind, the 5 gets squared too, 5 times. So it's going to be 5 root 2 times 5 root 2, which is 25, times root 2 times root 2, which is root 4, which is 2. 25 times 2 is 50 units squared. So that's the area. Area is always going to be squared, and perimeter is always just going to be units. Find the area in the perimeter of a regular hexagon that has side of 12. So if one length is 12, this is a hexagon. So the area of my polygon is going to be 1/2. A and S, apothem times number of sides times length of one side. So I have 1/2 my apothem, don't know that. I know 6 sides, and the length of one side is 12. All I need to do now is to find my apothem. Again, I'm going to cut this straight down. I know that's going to be 6. And I know that this will be a 60-degree angle, because remember, these are 120. If you were to remember any of the angles, like a hexagon, heptagon, nonagon, decagon. The one to remember is the hexagon. This is 120 degrees, always 720 degrees sum. Cut it in half, makes 60. This is a 30, 60, 90. Across from the 30 is 6. Across from the 60 is going to be 6 root 3. So I have my apothem now. My apothem is 6 root 3. So we're going to take this 2, and this 2 divides into one of these numbers. So I'm going to go 2 into this 6, and that's going to be 3 root 3. So we have 3 times 6, which is 18. And then I have 18 times 12. What is 18 times 12? 16. That's 3. 8, and that's 1. We have 6, 8, 9, 10, 11, 2, 16. So we have my area of the hexagon is going to be 216 root 3 units squared. You also need to find the perimeter, and the perimeter is just going to be 12 units plus 12 units plus 12 units. So basically all the way across. So you've got 12 times 6, and 12 times 6 units is going to be 72 units. So 72 units is my perimeter. Okay. Find the area and perimeter of an equilateral triangle that has an apothem of 8. So an apothem, keep in mind, remember equilateral triangles, okay? Equilateral triangles have a height. There's my height, okay? I'm going to do this 2 ways, okay? One way, okay, let me do this twice. Okay, so hold on one second. Okay, so what I'm going to do is I'm going to copy this. And now I'm going to, I think I'm going to paste it. Yep. And I want to do this 2 different ways. I want to do this one with my area formula for my triangle. Okay. So the area of a triangle is equal to 1/2 base times height. And I'm going to do this also, my area of a triangle, or a regular polygon, because it's equilateral, so it's regular, is 1/2 ANS. So I know my apothem is 8. So that's this point that comes right down here. That's 8. Now keep in mind that you have a height, right, that goes like this. This is 3 to 1. So that means this length is 8, 8, and 8. So the height from here to here is 8 times 3, which is 24. So that being, this also being equilateral is 60, that makes 30. So across from the 60 is 24. I'm going to take that value, 24, divide by 3, multiply by root 3, and I get 8 root 3 is A. So that would be this length here, okay? And then 8 root 3 plus 8 root 3 is 16 root 3. So that's the length of one side. So we have 1/2 times my base, which is 16 root 3, times my height, which is 24. Half of 16 is 8. 24 times 8, okay? 32, 3, 16, 17, 18, 19 is 192 root 3 units squared. And that's the area of my triangle. Now, the other way to do this, to find the area of this triangle, okay, the other way to do this is to use the apothem times the number of sides times the length of one side. So in doing that, we're going to go 1/2 my apothem, which they gave me is 8, times the number of sides. I've got 3 sides, okay? And now all I need is the length of one side. So let me put my apothem in here. There's 8. Now, you know, again, those are 60 degrees. All of these are 60. But when I do this and I cut that in half, that becomes a 30, 60, 90. And if across from the 30 is A, across from the 60 is A root 3. So that makes that 8 root 3, which is just from here to here. So that means this other side is 8 root 3 also, which means the length of one side, that being the length of one side, okay, is 16 root 3. And remember, 2 divides into 8 4 times. 4 times 3 is 12. So we have 12 times 16 root 3. So let's see, 12 times 16. 16 times 2 is 12. 6 times 2 is 12. 6 plus 1 is 7. 2, 1. So I get 2, 9, 1. So I get 192 root 3 units squared again. So it's up to you whether you choose to use the area formula of a triangle, which is 1/2 base times height, or if you use the Polygon area formula, which is 1/2 apothem times the number of sides times the length of one side. And you can use that in any of the shapes. Apothem times the length of one side times the... So what we have here is an octagon. Now an octagon has 8 sides, and we're trying to find the perimeter and the area. Oh, hold on, one thing. Find the area and the perimeter. I think I forgot to find the perimeter again. Let me just do that. We found the area coming back. The area is 192 root 3, but the perimeter, so the perimeter is going to equal 16 root 3 plus 16 root 3 plus 16 root 3. So 16 times 3 is 48 root 3. So 48 root 3 units is my perimeter for both of them. 48 root 3. Okay, find the perimeter in the area of an octagon. So the area of my polygon is 1/2 ANS. So it's 1/2 my apothem, which is 3 in this case, because they just said that. My apothem is 3, so that comes down here. The length, or the number of sides, it's an octagon, so it's 8. And the length of one side is 5. So actually, I don't have to do anything other than multiply for this problem. To find the area, I'm going to divide this 2 into this 8, which is 4 times. So I've got 12 times 5. 12 times 5 is 60 units squared, so unit times unit. That's my area. But if the length of one side is 5, and I've got 8 sides, to find the perimeter, I'm going to say 5 times 5 units times 8. And 5 units times 8 is 40 units. And that's my perimeter. So here's a couple of bonus problems. Find the area of an equilateral triangle that's inscribed in a circle that has a radius of 12. So again, circle, there's my radius right there. It's an equilateral triangle, which makes that a 30-degree angle. There's my apothem. The area of an equilateral triangle, the radius is 12. So that means across from the 90 is 2a. So a is equal to 6, okay, which is across from my 30 is 6. So 1/2 a, 6, and number of sides, 3, length of one side. So across from the 60 is 6 root 3, but the length of one side is going to be 12 root 3. So that's 12 root 3. And again, remember that this 2 will cancel into one of these terms. And so you'll get a 3 here. 3 times 3 is 9. 12 times 9 is 108. Okay, so we have 108 unit, or square root of 3 units squared. So that's my area of the equilateral triangle. That's this area, this shape inside, space inside. Find the area of a regular hexagon. So that's going to be area of a hexagon is equal to 1/2 ANS. So 1/2 my apothem times the number of sides times the length of one side. So again, there's some things we need to find. We need to find the length of one side. We need to find the apothem. Okay, so we do know that the radius is equal to 12. So this is equal to 12 right here. And this being my apothem, again, this is 60 degrees. Across from the 90 is equal to 2a. So a is 6. That means a across from the 30 is 6. Across from the 60 is 6 root 3. So that means my apothem is 6 root 3. the length of one side of my hexagon is going to be 6 plus 6, which is 12. Okay, so that's this value here. So I'm going to take half of one of these terms. So half of 6 is 3. So again, we've got 3 times 6, which is 18. And again, 18 times 12 is going to be 16. 2 plus 1 is 3. We have 8. We have 1. 6. That's 11. 2, 16. So we have 216 root 3 units squared is my area. All right, cool. So working in your groups to solve for the equations, this is just for any n-sided polygon. They're just talking about the apothem and P being perimeter. One of the things is that when you're using 1/2 A and S, the number of sides times the length of one side, these two terms here, is actually your perimeter. So another formula you can use for a regular polygon is not only 1/2 A and S, but it's also 1/2 A times P, and P being my perimeter. So again, the A is the apothem, the N is the number of sides, and the S is the length of one side. Okay, all right. So there's an exploration that is attached. I just want to reiterate a few things. Yes, you can use, for each of the shapes that we've talked about, like a triangle, I can use the area of a triangle, which is 1/2 base times height. But I also can say the area of a triangle is equal to 1/2 A and S, only if this is a regular polygon. So meaning regular, meaning this would have to be an equilateral triangle. If it was an equilateral triangle, I could use either formula. For a square, we know that that's regular, okay, because squares have all sides are congruent. So for a square, the area of a square, we can use side squared, okay? But you could also use the area is equal to 1/2 A and S, meaning 1/2 my apothem. Remember, apothems come straight down like that. That's my apothem. The number of sides, so A times the number of sides times the length of one side. So any of these shapes that are regular, now a trapezoid is not regular. A rhombus is not regular, but a 3-sided shape, a 4-sided shape, a pentagon, that's regular. The key word being regular. All sides have to be congruent. Then you can use 1/2 ANS. If it is not a regular polygon, you're going to have to split it up into triangles or some sort of thing in order to find the area of those shapes. So anyway, thanks for watching, and see you next time.